So I'm going to review some of the main points we talked about from class on Wednesday. And I'm not going to hit on everything just because we did some proofs, we did some informal proofs. You guys don't really have to focus on that. The main point is that you understand the lesson and the theorems that we talked about in the lesson. 10.4 discusses inscribed angles. And if you recall from when we talked about an inscribed polygon, inscribed polygon, the vertices of the polygon were on the circle. An inscribed angle, same concept. The vertex of the angle is on the circle. So angle CBD is an inscribed angle. So there is a theorem that says an inscribed angle measures half of its intercepted arc. So if I look at my picture, this angle here is an inscribed angle. You can see it intercepts this arc, and its vertex is on the circle right here. So based on this theorem, if that is true, since this arc is 2x, this angle has to be x degrees. So I'm going to go through a very informal proof explaining to you why that is the case. The first thing I'm going to do is I'm going to connect and draw my radius, a radius from A to C. So radius AC has to be congruent to radius AB just by definition of a radius. That makes this triangle an isosceles triangle, which means these two have to be the same. This angle right there has to be 2x degrees. Reason, it's a central angle and it's got to be the same measure as its arc. So if that angle right here is 2x degrees, this angle would have to be 180 minus 2x degrees, because this one and the blue one are a linear pair. Now, if I go back over here to my triangle, then all three of those angles have to equal 180, and because it's isosceles, I could find these two angles here by doing 180 minus this angle and dividing it by 2. So if I take 180 minus the red angle and I divide that by 2, it's going to give me angle CBA and angle BCA. Those are going to be the same, again, because it's isosceles. So if I distribute my negative, I'm going to be left with 2x over 2, which just equals x, which is what we stated in the beginning that our inscribed angle would have to be. We did another case of why that theorem is what it is. I'm going to skip that. We skipped case 3 just for sake of time as well. Then we went to the back of that worksheet and another theorem. This theorem is an angle inscribed in a semicircle has to be a right angle. And let's talk about why that is. If I look at this angle right here, inscribed into the semicircle, if you follow the ends, that's a semicircle. What's the measure of a semicircle? Well, it's 180 degrees. If you take half of 180 degrees, that leaves you with that right angle. It doesn't matter where that angle is, as long as it's inscribed on the circle, and as long as the side across from it is a diameter, this is always going to be a right angle. Okay, so anytime you have a triangle inscribed in a circle, if one side of that triangle is a diameter, the angle across from it is a right angle, and you have a right triangle. The next theorem we talked about is what happens if you have two inscribed angles that have the same intercepted arc. So that would be like this angle intercepts this arc. And so this would have to be x degrees. This angle intercepts this arc, and if you look, it's the same arc. That would have to be x degrees also. So that means those two angles would have to be congruent. And the last theorem we talked about states the opposite angles of an inscribed quadrilateral are supplementary. So that means this angle and this angle add to get 180 degrees. And let's talk about why that is. So the green angle follows that arc, and the blue angle follows that arc. Think about the concept that an inscribed angle is half of its intercepted arc. Well, if I put the blue and the green together, the total would be 360 degrees. But then when I look at the angles, I would have to take half of that, which is 180. So these two angles put together equal 180. These two will equal 180. It's only going to work on a quadrilateral, but anytime that happens, the opposite angles are always going to be supplementary. We then did this worksheet together, and I kind of guided the students on how to best approach this. So if we follow along on this worksheet, I'm going to mark everything in the circle that I can before I go and fill in my answers. So I'm going to follow my inscribed angles. If I follow this angle right there, well, it goes with that arc. And I'm going to erase some of my lines. So the angle 30 goes with this arc. If they give me the angle, to get the arc I have to double it. So the measure of that arc would be 60 degrees. If I follow the 60-degree angle, that goes from there to there. Double that, it's 120. And if I follow the 50-degree angle, double that, that's 100 degrees. So now I really only have one arc remaining. It's 360 degrees all the way around the circle. So I can take 360 minus 60 minus 120 minus 100, and that's going to give me 80 degrees for that part. So we'll do that for that part. Now, if you notice, you've got other inscribed angles going with these arcs. So if I look at the red arc and I follow along, if I follow this way to this angle here, that's another inscribed angle that goes with the 120. So that has to be 60 degrees. If I follow the 60-degree angle, well, I know I got it from this angle here, but I can also follow it this way to that arc, to that angle. That has to be 30 degrees. I do the same on the 100-degree arc, and I follow the other angle, which is this one right here. That one has to be 50 also. Then I can go in and fill in the angles that go with the 80. It's that one, and it's that one. And you can follow along with your pencil on your paper. It's easier than me doing it on the whiteboard and messing up what I already have. Now, if you look, we've got those 4 angles remaining, but each of those are triangles. So if I look at this angle right here, 60 and 40 is 100. Take that away from 180, and I get 80, which makes that angle 80. These two are a linear pair, so that has to be 100, and that has to be 100. Now it's super easy to go fill in your sheet. You should have done that through the notes that I put online. Again, for sake of time, because the bell's about to ring, I'm going to skip on down and try to get a couple done on the next page. Sorry, at the bottom of this page. So on this one, if you notice, you have both central angles and inscribed angles. You also have parallel lines, which means you're going to have some alternate interior angles. You also have to be careful because this whole red angle that I just marked is that. But you also have this angle and this angle. And I'm going to go ahead and mark those congruent because if you notice, it says X is the center of the circle. So these are radii, which makes that an isosceles triangle. You're going to follow the same procedure as before, but it's not just inscribed angles. You've got other angles involved. So I'm going to stop there. I wanted to make sure I got the video posted. Come to tutorial and ask questions, copy the correct answers, make sure they make sense, and I will just see you guys in tutorial.